Excellent. Oh my gosh, you guys, I have some treasure, and I haven't done a live stream in a little bit, so I wanted to do another one. Done 3 other types of videos, and I'd like to do another live stream. Let's tear into some of this stuff and see what's going on. What an exciting time, guys. I am going through stuff that I found in the trash, and I tell you what, I love finding stuff in the trash. I really do. Hold on just one moment. There we go. That's better. All right. I'm so very excited. This little scale here that I just did a video on yesterday, I just finished putting it back together because honestly, I didn't really care to put it back together. And it is working perfectly fine. To this day, I honestly have no idea what was wrong with it. I'm thinking I'm seeing evidence of drop damage, you know, here and here and here on this front corner. There's normally these little suspension arms that hold this pan, but they're not there. It weeble wobbles, so it's obviously been dropped. A little bit of evidence was on this front wheel, or this front leveling foot. It's got a flat side right there, so it was obviously dropped. And guys, this is going to be one of the craziest things. Hold on. So this is the AC adapter that was with the scale. It was zip tied to the scale, and it almost looked like a zip tie that I would have put on there. So I think I was the last person that did this. But anyway, the ratings on this transformer, which, can you hear that? That's interesting. It's rattling around. I might open it up just to see what the hell's going on. So here's an interesting thing on this guy. All right, it says that it's DC 12 volt 300 milliamps. Okay, and you guys seen from that video that this scale here had an error code. Who cares what the error code was? It's obviously working fine now. I can do measurements, and they got to be pretty close to accurate. But this guy that was attached to the scale says it's 12 volts. Here, check this out. I'm going to plug it in. See, you got to be aware of the overhead lights because you guys can't see so well. All right, let's see. So let's take a look and see what this guy is kicking out. Oh, hold on. Oh, my guy. Do you guys see that? I don't know if it's inverted for you guys. Yes, it's inverted for me. It's reading 22.46 volts. And it is very consistent. Very consistent. It's not like it's changing. So it's rated at 12 volts. It was definitely 12 volts when I put it on the scale, but they dropped it. Now it's got a shaking sound, and it's putting out almost twice the amount of voltage that it's normally supposed to put out. How about that? Pretty crazy. Now, just because it's got voltage doesn't mean it's got amperage. So if there was a short inside the transformer, inside it, which is what I assume is what happened, then, you know, it's probably not going to have the amperage. And obviously, I'm not putting out very much amps to power the scale. But I'm thinking that maybe that is part of that error code as well, is it was an overvoltage. I have not looked up that error code yet, but I will. Hold on. Thank you. Okay. You can come over here and help Daddy, okay? All right. Okay, you gonna stay here? Okay. Oh, it's okay. Leave him there. Okay. All right. So here's the power supply, and I think maybe later on I'd like to break it open and see what the hell's going on. But I'm going to put the scale to the side because it's working. Now, the stuff that I found in the trash. Look at this beautiful piece of machinery. Any of you guys that have worked on ventilators, you probably know what this is. This was in the trash, and it is a servo motor. We have the 3-phase lines right here that make it a 3-phase motor, and here is the encoder lines that dictate the speed or the position of the motor. We'll know if it's speed or position because honestly I have no clue what this device came out of. I know it's a vaporizer or a ventilator, but obviously a motor this big would be your motor that is used to compress air, right? And I suppose I could look it up, but look at the quality of the machining on this guy. It's beautiful. Medical parts, I'm guessing that this part here was probably made in Switzerland. That's my guess. I'll probably look it up later. Or maybe we pulled the motor off the transmission here, and maybe we'll see. But let's take a look. I want to see what's inside this bad boy because I have no clue. And I don't think anybody that's pulled these out of equipment have ever looked inside to see what the heck it's really made out of. So let's see that now.
Yeah, I don't want to draw.
You want to what?
I don't want to marker.
Okay. There you go. Okay. Get your markers. All right. Let's see. I bet you it's metric. And those are probably what? 6. Nope, way too big. 5. What? 4.5? I don't know. That's 4. I don't know if you guys have ever done this, but sometimes a Torx fits in there a little bit better than anything else. There we go. Jeez. Just the machining on the sides of this is so perfect. There is no ledge there whatsoever. It's almost like it was milled after it was put together. That's absolute precision. Those are really torqued down too. What's that? Thank you, sweetie. I know, you're always going crazy in the house.
Yeah, I don't say manga was there without a marker sword.
With the marker sword?
Yeah.
That's fantastic.
We are pretending.
Oh, this is just taking forever, isn't it?
Yeah. We're pretending.
What do we got?
It's real.
It's a T30. Hold on. We're going to speed this process up a little bit. A little bit of this, that, right? All right, now we're going to pull out the big gun because I'm not goofing around. Wow, is it really standard? That is so crazy. I would have thought for sure that this would be a metric part. Maybe it was made in Japan? All I can think of is made in Japan because is it really possible that this was made in America? There we go. There we go. I know. Holy cow. This has got to be one of the craziest things. That just goes to show you the precision, man. One T30 it fits, the other T30 it doesn't. How am I going to pull this off?
Oh, I forgot
What's
lock.
that?
I forgot lock.
Oh, yeah?
Yeah, lock it over there.
Just for this, I'm going to have to whip out some Harbor Freight tools.
Yeah.
And I imagine that this this motor right here costs thousands of dollars. Thousands. Jeez. Not that one.
I need my black marker there.
Okay, then go get your black marker.
Okay.
Go get your black marker. One of these darn things is going to work, guys. What's that? No, put it up there.
I don't want it to fall.
Well, then you're just going to rebuild your marker tower, huh? There we go. Wow. Could it be that these are really a special size fastener? Like they really don't want me pulling it apart? There we go. All right. There we go. This one is going to work. Wow. That is very, very, very awesome. Oh, sweet. I love you, but I can't talk to you right now. Okay? Want to go in the house?
No.
No. Okay. You gonna be quiet?
Yeah.
Okay. Thank you. Here. Why don't you raise up so you can see what we're doing? Okay. Guys, this is what's very cool about this device. So it's set up with an offset weight on the motor, and it shakes this piece right here. Oh my gosh, I see what this is. So if you guys seen my video recently on air conditioning systems, then I did one on a scroll compressor, and this is a scroll compressor. How crazy is that? Here, I'm going to pull it apart to show you guys. It's actually offset. Yep, see, look at that. That's exactly what it is. You can see the scroll end opening right there. How crazy is that? I wonder what pressure I can get out of this. So that means that this right here is the output, and right here on the side is the input. That's very cool. So why would you trade out a scroll compressor? That's weird. I see these things all the time in the trash because after a certain number of hours, they're required to change these guys out. But look, they have serial number bearings. Each of these bearings has a serial number. Here, here, and here. Maybe the bearings eventually start going bad. But you would think that they would just come and change out the bearings and you'd be good. I must be too much of a pain in the butt. So you've got one bearing in the middle, bearing, 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 bearing. Wow. Very cool device. I'm going to pull the scroll off so you guys can take a look at it. Yeah. Hold on, sweetie. Whoa. You can see what it does right there. Now, how am I going to hold that still? Because they're blind. I don't know. Here. All right, let's go, big girl. Oh. Let's go, let's go, let's go, let's go, let's go. Up, up, up. I know. Okay, bye. Sorry about that, guys, but the family wants to participate as well. So how am I going to get this? Okay, I think what I can do is I can jam the scroll, and that's how I can pull them out. Something like that. It's going to be harder than I thought. It is clearly not designed to be pulled apart. Let's try it right there. All right, that did it. They're not on very hard, not at all. It's just when you got that many bearings, you know, path of least resistance is for it just to vibrate the bearings. Okay, there we go. Oh, very cool. Look at this. All right, hold on. Let me clean up my work surface a little bit. You can see how I can create a mess real quick. Okay, so this looks like a Teflon bearing, which mates up here, and then this Teflon bearing matches up on the inside. Very, very cool. That means that this pump is perfectly good. It can keep going. Take a look at that. So they just sit inside one another, like so, and then they vibrate. So if you haven't seen what this type of compressor is, go ahead and take a look at my video on refrigeration systems. And I went over this type of compressor. Man, how cool is that? This has got to be one of the coolest finds. And this was in the trash. I found this in the trash. I pulled it out, and I am so excited. So it's really funny because all of these things here are like a matched pair. And I wonder if it's matched for balance. It's got to be for balance. So it says 104, 104, 104, and somebody's inscribed right on each and every single one of these. You see that? Right under the 104, there's actually an inscription. So, wow, this is really built with precision. Very, very cool. All right. So let's see. This is very neat. Since it's a three-phase, that means I can power it with a little inverter. I'll do that sometime. That'll be very neat. And here's the motor with its offset weights. Again, I can tell it's been balanced based on the inscription. And right here, some of the balance marks as they grind away on it. So I bet you this thing is perfectly balanced. So very cool. Everything's got a serial number. There's a serial number here, serial number here. There's serial numbers on all these bearings. What a neat find. But anyway, that is a three-phase motor, and right here is the encoder. So the encoder is actually for speed on this guy. I'm going to go ahead and pull the back end off so y'all can see what I'm talking about. Oh, geez, I got some stuff up here. On over. Okay, for these, I'm going to need one of these tools. There we go. None of these are really, really tight. They're just very, very precisely torqued down. I can tell by the sound and the feel to break them loose. Very precise. Of course, it'll never, ever be that much precise after I get through putting it back together. Sneed says, how much networking do you actually need to know on the job? From your videos, I'm guessing as long as you know how to use Excel and understand CMMS systems, you should be good to go. For the most part, yes, you're right. For the most part, you don't really need to know medical networking, but as you progress with your career, you will probably want to know some more of it, because I do medical networking. Hold on 1 second, guys. Oh man, sorry about that, guys, but I do believe I heard a child crying or screaming just a moment ago. Kind of crazy. Come on. You gotta be really careful here because I have no idea how long these leads are under this cap. Oh, very cool. Okay, so behind this is a rubber grommet where they're all inserted one by one. Oh my gosh, that could make this such a pain in the butt to pull apart. All right. How do I get it apart? Any ideas? Let's see, there's a little tiny set screw there. Okay, so yeah, I'm gonna pull the housing here off. All right, so there are 3 Phillips screws, 4 on the inside. I'm gonna zip those out. There we go. And what is going on? Are my neighbors fighting? This is crazy. Oh my gosh. that's the wildest thing that's happened today. Guys, my neighbors are my neighbor lady is screaming, I think at her husband, and in Chinese. So like she's screaming so loud. And I do believe the whole entire neighborhood knows now. Wow. So getting the set screw out is going to be real fun here, I can tell. Because it is in good. I might have to heat that up. I think they use Loctite on it. There it goes. Wow. Oh my gosh, guys, that is in there. Hold on. It's time to use the torch. So I've had several people ask me why I keep torches around. And guys, this is why. When you're dealing with Loctite, sometimes you just gotta blast it with a little bit of heat, man. Come on, there it goes. See? It just takes a little bit of love, man. There we go. One quarter turn at a time. Okay. Right, there it is. There it is. Whew. I'll just leave that guy right there. And it comes off. Wow, the machining. Look at those machining marks in there. It is perfectly smooth. Guys, I appreciate fine machining. That is beautiful. Everything is so nice. Like this O-ring back here, just perfectly lined up. All right. So there are replaceable bearings. It's just a clip. Are these guys fighting out in the street now? Oh my gosh, guys, this is so crazy. Ah, my gosh. Hill Round Nurse Call, you know something? I got a power supply right here that I am dying to tear into. If I can't get this motor apart, because I don't want to damage the electronics, then I'm just going to go ahead and leave this motor. It's on there. Oh, shit. Because if I do pull it apart, the chance of me ever getting it back together with that kind of precision are not very good. So I wonder how much torque is on this guy. Because usually when they increase the diameter of the motor, it's got a little bit better torque. This is excellent. All right, I'm just going to put these screws back in the cover. And I'm going to shove this guy off to the side because I want to tear into this Hill-Rom system right here. That is so cool. I love it when products are made really well. And of course, this guy is crazy expensive too. I mean, this could be a $5,000 or $10,000 pump right here, depending on what it goes to. All right, let's see. Anyway, that is a three-phase motor, or actually an air compressor. It's a three-phase air compressor, scroll compressor. And guys, come on. It's such fine tolerances that if you try and pull it straight apart, it's not going to go. But this is such a cool find. It's so tiny. Put this guy back on. All right. So let me find a place for this guy. Here we go. I'll leave those there. Excellent. All stainless steel fasteners. None of them stripped out, even though some of them are in there really well. Let's take a look at this bad boy. All right. So Gregory, you say you've torn open Hill-Rom systems. Have you ever opened one of these? So this is a Hill-Rom Nurse Call PDC power supply unit. And I have no idea why we have so many of these in storage. We have so many of these in storage. So I'm going to tear open and check it out. I see that there's one controller card on the back. Aha. All right. Nice. Okay, so what do we got? We got a step-down transformer. We have a very large smoothing capacitor back here. Guys, I think my neighbors are killing each other out there. Here, hold on. I wish I could show you guys this. Maybe I should just open my garage and let you guys see what's going on. Give me just a minute. It sounds like somebody's ready to kill somebody. It's really crazy. Like she sounds like she's getting beat down out there. All right, guys. So I verified that nobody's getting beat down, but they're probably getting divorced after tonight. All right. Let's see. Our Hillrom is power over the Ethernet. Oh, you got a new Hillrom system. Lucky boy. Let's see. Hold on. I'm trying to catch up to all these. Oh my gosh. So much. So have you ever worked on dental equipment? I most certainly have. Where I came from in the Air Force Biomed, we started out in dental. Yeah. So yeah, we did a lot of dental, and I could do anything to dental, anything you need. That's one pretty motor. Thank you, Patrick, for appreciating that motor. The crazy thing is I see these in the trash all the time, and it's an air compressor motor. I wonder what pressure it can obtain. Probably pretty high, because that same type of scroll compressor they use in air conditioning systems, which have to get to 100 to 200 psi. That's a lot. That's a lot. That would be a brushless motor. Yes, it is a 3-phase brushless motor for sure. Gregory says, I got your channel from my Biomed boss. Unfortunately, I'm fixing to drive home from another hospital, so I can't stay. Gregory, check out the channel, man. Thank you for tuning in. I do teardowns and stuff like that, and just crazy stuff. I found this stuff in the trash, so that's why I'm tearing it apart. And if it doesn't go back together, then who cares? But check out the channel, and thank you for coming by. That is awesome. Kind of hospital contracts us out to other. Oh, they really do? They contract you out? Where are you coming in from, Gregory? That sounds really interesting, man. That's very interesting, actually. So anyway, let's take a look. As I was saying, guys, we have the AC that comes in probably down here on these black and whites. Comes up here to the front power switch, and from there we've got, oh, what does it do? It looks like it's coming straight down to the primaries on this transformer. And from there, I have 2 wires coming out to the front cap. And off the secondaries, I have a 12 amp breaker. And then I have my bridge rectifier, which is this big old square right here on the back. So that's where it converts over from AC to DC. Once it goes to DC, it comes into my circuit board back here, where it's going to hit some voltage regulators, okay? I'm looking to see if there's any fuses or anything on that board. It looks like this is a very serviceable board, and this is probably the only thing that really breaks on this whole entire system. So if this system is going bad, these components here, there's a Teflon fastener on them. You can change those out, desolder those. You got a diode on one, and the other one here is just a little MOSFET. And here, what the heck is this one? I can't see what it is, but that's probably a voltage regulator right there. It says a slow turn-on circuit. Okay, so that makes sense. That makes sense. So it charges up the cap, and it prevents that surge of current. Anyway, that's why you have this giant heat sink back here. It's because of the bridge rectifier is obviously going to take quite a bit, and it looks like the rest of it is going right here to your diode and MOSFET. Not very complex at all. I do not see why we would need to keep 20 or 30 of these in storage like we currently do. These things are heavy, man. I'll tell you right now. This guy probably weighs 30 pounds. It's probably pretty close. But yeah, man. I bet you it works too. So if this is a 36 volt, 8 amps power supply, 8 amps, 36 volts. Wow. This guy's putting out some power, man. I might just power this guy up and see if it works. Just another thing that I kind of found off in the side by trash. And now that I've proven it's not very complex, I don't think we need to keep so many of them. Maybe we can fix them from now on. So that is the Hillrom power supply. So I hope you guys are starting to see a trend in some of my videos that once you know the stages of a power supply, you know what to look for. And once you know what to look for, now you know how you can fix them. Because there's one thing that's going to go bad in all medical equipment, and that is almost guaranteed to always be the power supply. It's just the way it is. What is going on here? Am I doing something backwards? There we go. Jeez. So now that I know it's not a very complex device, I'm going to ask that we only keep 3 or 4 of them on hand instead of like 20 or so that I currently see. And if they go bad, we'll just fix them. There's really not too much to fix. All right, I got one more thing that I want to go over with you guys, man. Actually, you know something? I'm going to save that for another video. I'm going to go ahead And I'm going to tear into this little power supply right here because I am dying to figure out why it's kicking out 22 volts. It's kicking out 22 volts when it's rated for 12. All right, so there's a couple different ways we can crack this guy open. Let's see. What are these little mighty mites? It's gonna take too long. This guy. All right. Hold on. Let me get a flathead screwdriver. Yes. All right. There we go. Okay. Well, if you guys seen what I just did, so what I did is I put it in a vise and I put pressure on the two sides. And then what I did is I just separated it at one corner. And because you put pressure here on the sides, it will just naturally want to open itself up very violently. Wow, this is so cool. Okay. So I can see it looks like one of my diodes. Look right there. Looks like this diode has kind of unsoldered itself. You see that? There it is. Holy cow. Well, it definitely had some sort of epic meltdown. These stupid cameras with their autofocus. Guys, someday I'm going to convert over to a manual focus camera because it's a set distance. Why do I need autofocus? It's so crazy. But yeah, so that is it. There's two ways to test this. One way would be to measure the coils, and the other way is just to notice that this thing got crazy hot and started messing with these diodes over here. Yeah, I mean, I've got traces that look like they're almost shorted over. You guys can see that molten mess on the bottom. So it's boogered. It's royally boogered. I was expecting as much. But I wonder if that happened because, see how this guy's free floating? That was molded as part of my transformer. But when it broke, I think what happened is it boogered some of my coils right here. And, you know, if any of your coils short together, it's going to change the properties of the transformer. So that's why it was shaking around. Normally it's anchored by those plugs, but it was just weeble wobbling around. And obviously putting out twice the amount of voltage that it's supposed to, that's why those diodes got really hot. So this is a fire hazard. I'm glad. If you guys ever hear one of these little transformers and you can shake them around and they're making a lot of noise, get rid of it, okay? Do not keep that thing in your house, because if something loose in these things, it is a fire hazard. All right, let's see. What is this? Have you guys ever seen one of these before? This is a Kangaroo Joey pump. And I have so many of these, it's not even funny. I have lots and lots of these Kangaroo Joeys. Man. So I figured I'm going to take one home and I'm going to butcher it. And we're going to open this bad boy right up. That's what's going to happen. Hold on. All right, so Kangaroo Joey pump. This is a feeding pump. And I mean, you can use it for lots of different things if you need to, but I think they mainly use them for feeding. Anyway, this is a peristaltic pump, and notice this thing. It's got a sprag clutch, which means it's a one-way clutch. You can see I can rotate it counterclockwise, but it will not go clockwise. It's very cool how sprag clutches work. But anyway, here on the set, if I remember right, you can see how it's got these grooves where you put the tubing in, it goes around the pump head, and then it comes back up into here. And right here is a gate valve, okay? So what that's going to do is that's going to divert flow right here on the output, I think. Anyway, I have never ever done a PM on a Joey pump. I have never opened one, and you know something? Other than knowing the general how it works, I've never dealt with these whatsoever. So that is why I brought it home, because I want to learn what the heck is going on inside this. So this, I'm guessing, either has a ultrasonic sensor or more likely a magnet sensor, which is also called a Hall effect sensor. So there's a magnet you can see in the little diagram right here of the tubing set that you put in. So there would be a magnet on the tubing set. So when you put it in there, the pump knows that there's a consumable loaded and it's ready to rock and roll. So that is how it works. I'm going to go ahead and start by pulling it apart in the back. Let's see what's going on. So this is probably the battery cover. I'm just curious because these items here were just given to me on a whole cart, just a whole bunch of these things, and we didn't even know that we were going to be the ones servicing them. So here we are. Come on. She's being a little fussy. Okay. Wow, look at that. Look at the difference in fasteners on this guy. Don't lose that fastener. You will not find one of those again. All right, now that I got it off, yep, there's the battery pack. Excellent. All right. So I can see right above the battery connector, you can see that there's another connector right here, and that is either for options or for more likely programming. You know, probably to update the drug library or whatever else that these things do. It's kind of like a hidden port that we never use, but the OEM is going to use it. Oh, that battery's in there. I hope I do not ever have to change out these batteries, because I'll tell you right now that that's going to be such a pain in the butt. How do I get that out of there? Just pull up on the wires? Ugh, I hate doing that. All right, so this is a 2019 battery, lithium-ion cells. These are 18650 cells. Yeah, it's all right. I wonder who makes the cells. Oh boy. All right, so I can see an optical interrupter disc. Let's go ahead and pull this guy apart, because an optical interrupter disc is how the motor keeps track of how many RPMs it is creating and how much it's infused. Oh, let's see. Let's try this one. All right. Today is my night for quality built products. So around the fasteners, there's a rubber grommet that's molded to the fastener. Don't lose that. You'll never find another one. here I am taking this apart, and my my disassembly mat is right over here. I should be using it right now. Let's see. Mark says it switches from feed to flush. Well, there we go. All right, that completely makes sense. I've never set one of these things up before. I don't know. What? Oh, that's beautiful. That is beautiful. Okay, so it looks like it comes out as an assembly, but I've got to get it past that optical interrupter disc. How do I do that without breaking something? Carefully. Oh, very cool. Come on. I definitely need to get this out now because there's some stuff going on in here that you guys got to see. All right. Here we go. So I see 1, 2, 3, 4. Man, there's a whole bunch of ribbon cables in there. Hold on. Let me change this so y'all can see a little bit better. Because this is very cool. I do not want to miss this. There we go. So there's that photo interrupter disc I was talking about. You can see that there's a bunch of lines in there. And as the motor turns, it counts the pulses that are created on the optical interrupter over there. Hold on. I'm trying to think of the best way to pull this apart. Let's try it. Whoa, another really long fastener. Okay, so how? So that holds the front face on. I guess these two right here. All right, there's one. I would not want to be a depot and servicing these. I mean, it's really cool how it pulls out, but because they zip tied all the lines in there, it's actually a pain in the ass because now the front face, I think you have to pull the front face off in order to get to the, yeah. Look at all those connections in there. Yeah, that's a pain in the butt just because they put this zip tie here. There we go. All right. Let's see. I'm going to go ahead and pull these lines for the motor. Wow. Those are definitely delicate. Come on. Let's switch to one of my smaller. It's nice having these benchtop precision screwdrivers when you got to do this stuff. Okay. Here we go. Better. Oh. Okay, not so bad. So the CPU and everything is right here on the front face. That is pretty much everything there. It's obviously got your it's got your membrane buttons that route to one side, and it's got your video on the other side, or vice versa. This one's video and this one's membrane. Very cool. And it does all the voltage regulation and everything right here on this one board. And what is this? Okay. So this looks like a charge controller. So this one right here is probably like a float charger for this lithium ion cell. Very cool. It just kind of slides in. Hold on. These are still all tangled up down in here. That is chaos. There we go. All right. So what do we got? So I think that is the speaker right here. I believe so. Wow. So I think we got a speaker, we got the power input port. This right here is for the battery. These yellow and blue. And it's your battery maintainer circuit. Let's get to the real good stuff. Look at this. This is why I had such a hard time, guys. There is 3 photo interrupter discs on this guy. So you can see right here as I rotate the peristaltic pump, which has the sprag clutch, as it goes through, it pulses. There, out of 360 degrees, there's 3 pulses. You can see it right there. So that's how it keeps track of the motor. Wow. So you got high resolution on this one, low resolution on this one. I would love to talk to whoever designed this to find why they did that. Why would they do that? So notice how this one is not attached to this one. See? If I rotate this one, it spins the peristaltic pump. But if I rotate this one alone, it does not rotate this one. So there is no direct gear linkage between the two. Maybe something to do with that sprag clutch. I think so. Look at that. There it goes. You can see it there. And then there's this guy way over here. Okay. So this one over here is that diverter valve that he is talking about. And it looks like there is 2 pulses on that. So they're 180 degrees out. So it knows if it's open or if it's closed based on this disc over here. I mean, it's simple. It's all very simple. And these really fine wires right here, these guys right here are probably for that Hall effect sensor that I was talking about. That's probably in here. I guarantee it's got one. Let's see. Let's go ahead and take a look. This is a teardown. What fun would it be if we didn't really tear into it, huh? Let's see. I wish you guys knew how bad my dog stinks right now. I don't know what she ate today, but God, jeez, this is so bad. I'm like tearing up here trying to talk to you guys. It's so bad. All right, last one. All right, and 1 set screw for the drive wheel. This is what I'm looking for, this guy. All right, there we go. Oh, very cool. Okay. All right, here we go. All right, well, I got to be careful because it's held together by 1 ribbon cable. How crazy is that? Okay, so it looks like there's 1 ultrasonic sensor and 1 Hall effect sensor. So it detects when your fluid is out, and it also detects when the set is loaded. I'm guessing that this one that's over here, that's epoxied in, I'm guessing that this is the ultrasonic. You can tell it goes through a little cavity right here. And anytime you have an ultrasonic sensor, it's going to be in a spot where the tubing is kept really, really close and kind of pinched in there, because it's got to have very close proximity to get a good reading. Wow. All right. Well, very good to know. Right, let's see. I'm going to finish pulling this guy out. All There we go. All right. Haha! It is indeed a Hall effect sensor. Okay, so these guys right here, let me get them up nice and close for the camera. So you see these little guys right here that look like they're miniature transistors. What they are is, if you could imagine a transistor that turns on whenever a magnet gets close to it, not touching it, but just close. So all you gotta do when you put a set in, the set comes here and it activates it. It says, hey, I got a signal, go. And that's how you know it loaded the set. Yep, so that is an ultrasonic sensor. And something else right there. I don't know what that guy is. Oh, yes, I do. Yes, I do. Okay. So what they have is they have a sender on one side and a receiver on the other. So one of these is the sender, one of them is the receiver. It's not all in one bundle. See how there's only 4 wires? Okay. Interesting. All right, so these guys right here, this is an excellent view. See this U-shaped object right here? This is a photo interrupter. This guy right here. So on one side, there's a little diode, and it's shining light over to the other side, and it's receiving it. And what happens is when there's this little gap, and when it shines the light and it registers on the other side, it registers as a pulse. And whatever the math is inside the CPU, it determines how fast the pump is moving, or it determines the diverter valve, its position. I wonder if I can get this guy off. I really want to take this guy apart. I really don't want to take that optical interrupter disc off. All right, 1 screw. It looks like there's 2 screws holding it together. Wow, here, I better clear this out. Better clear this out, or else I'll get these parts all mixed up. Okay, there's 1, there's 2 plastic screws, and very gently, I don't want anything spring-a-spronging on me. Okay, all right, well, that's a surprise. There's 1 bearing right here with some needle bearings in it. So instead of a typical roller bearing setup, there's needle bearings. Come on. Can you see them in there? Maybe not. Anyway, there's needle bearings in that guy. Right, I want to see if I pull this guy apart. All right. This right here has an embedded sprag clutch. And you can kind of see it right there. Hold on. This is really important. So let me get a flashlight. There you go. Okay, I hope the camera can pick that up. So there's things in there that look kind of like needle bearings. These cameras are going to drive me absolutely crazy, guys. Okay, well, there you can kind of see it. Okay, so there's little needle bearings in there, but these bearings aren't in a fixed position. They're actually they're actually sitting in grooves that are kind of like a cammed groove. So when it's rolling, it's down in the groove, but when you go the opposite direction, it kind of comes up on a raised portion and it pinches, right? So when you got a bunch of these guys and you're rolling and then you reverse the direction, all those little rods, they kind of raise up on these ledges and they pinch down on the shaft. And that is how a sprag clutch works. Very cool that they incorporate it into a little composite gear. Very cheap, quick to manufacture. No sprag clutch components want to fall out. That's another problem I've had with these in the past, is they want to kind of fall all over the place. So that makes sense why one will spin and the other one would not, because it was hitting that sprag clutch and it was not wanting to turn it. Very cool. Also, one of the other things that you can see from this point of view is the diverter valve is directly linked to all the other ones. So as it rotates, it's just casually diverting, every so many revolutions, it automatically diverts. That's a cheap and efficient way of doing it too. Yeah, that's held on. I don't want to pull that guy apart because I'll never get that back together. But this is a well-made part. There are bearings. You can see this bearing seated down there in that cavity. So it's built really well. These little joeys, you can see that they're kind of designed for years worth of service. There's a kind of a high viscosity grease on all these gears, and it's getting all over me here. I honestly didn't really think that there's going to be any grease inside this, but here we are. All right, and it looks like, all right, so what I said was a bearing with needle bearings on the cover. It is not. It is the other sprag clutch. So there's two sprag clutches. It grips on the housing and it grips on the shaft if it goes the wrong direction. That's interesting. All right, let's see. I'm going to go ahead and put that guy back together. Now, I do have my DC power supply set up, so I could hook these bad boys up and I could give it a hot supper. Just see how fast I could rotate it. This is probably, let's see, 3.7 volts. So is it really just a 3-volt motor? Yeah, these are running in parallel. So it's only 3.7 volts for this little motor. It means I could hook it up and just light her up. Life to Lights, welcome. Mr. Dennis, you are absolutely correct, man. Bring a positive vibe during the interview. And it is absolutely essential, man, because we know if somebody's full of shit. We do. So just be positive about it. And even if you don't get the job, treat every interview as practice, man, because that's the one thing that you're going to get out of even a failed job interview is the practice. And maybe you just couldn't conduct yourself properly when they asked you a question. Well, now you know the general type of questions that they're going to ask you, so be better prepared next time. Yep, there we go. Very cool, man. All right. Well, I don't think I'm going to bore you guys with putting this bad boy back together. I will probably do this tomorrow. I got this weird grease all over me. So it was more complex than what I anticipated. But then again, they simplified it by putting like all the computer boards on this one board that also controls the display and the membrane buttons. Surprised. That's cool too, because you can sell, just the part, or you can just stock this one part in your depot. Very neat. Well, guys, let's see. I'm gonna raise this back up. So is there anything else that you guys would like to talk about, man? Danny says he just worked on a kangaroo pump a week ago. I've never worked on the Joeys. I've only worked on kangaroo pumps, and their calibration can be an absolute pain in the ass because you have to fill that reservoir perfectly, and if it's not filled perfectly, it's going to fail. So I'm in there, man. I get it. So Rodney, well, thank you, Rodney. I am glad that you are here, man. We are all glad. This is actually a community. So well, it's my channel. You're going to be surprised that the people that tune in here, a lot of them know each other, at least through the chat on these videos. So if you ever have any questions and you see me online, just come on in and shoot your questions, man. I'll tell you one thing about DaVita, and not to shit talk a company or anything. It's an excellent resource for people that are getting started in biomed. But DaVita is, I don't know, is it an entry level position? From what I know, they might not pay as well as other biomed jobs. That's just from what I know from what other people that have worked there. So it's an excellent in the door opportunity, but when the time is right, move into another job because this whole entire career field is about growth. It's all about growth, man. So staying in one position for your entire career, you might be happy. Go, more power to you, man. But if you want to chase dollar bills or a good position, staying in one position in one hospital is probably not always the best way to do it. Filter, heat filter. Jesus, you are not kidding. I used to assist with dialysis, and I mean, you get to work with your hands. That's for darn sure. You're gonna be tearing into some stuff. I hope you're good at documenting because dialysis gets inspected, and it is some serious inspections. Dennis says, "Is my neighbor still fighting?" I don't know. I thought I heard some cops. Like I thought I heard some sirens like a street or so away, and for all I know, they might have hauled somebody off. But it sounded like he was gonna kill her out in the driveway. This chick was screaming so loud, it was crazy. And they're screaming at each other in Chinese, so I don't even know what they're screaming about. It is what it is, man. Dennis says, always bring a positive attitude during the interview. These senior people can sense your personality during the interview. If you've got a good work ethic and a good attitude, you'll get a DaVita job. You'll get it. And like I said, it's an excellent place to get a start. So that's what I'm saying. I'm not going to shit talk a job. It's always consider a lot of, especially Biomed 1 jobs, always consider them as entry level and use it as a learning experience. Okay. Just celebrated a coworker's 40th year at my facility. I can't imagine staying at one shop that long. So, you know, given I'm very biased because I've been to a lot of different shops. One thing I can tell you about people that have been at shops for a long period of time is they think they know the right way of doing things, and it is likely not the right way. Okay. And the thing is people that come and go from other shops, every shop does something really well, and they do some stuff not so well. So it's breadth of experience, right? So the more shops that you've been to, you have an experience with all these different methods, and every shop does something well. And you know, people that have been at shops for a long period of time, they like things to keep going the way that they've always gone. And we are a career field that's going with technology. So that's the one thing. If on this channel I sound like I'm down against baby boomers and stuff all the time, guys, it's because we have to do more with less. And it seems like a lot of these older technicians, they want to print out all these paperwork orders and run around looking for this item or this item. And I'm all about paperless processes. You know, I'm using spreadsheets. I'm using barcode scanners. I'm using all this stuff. And they think like they don't always like what I'm doing. But the thing is, we have to do more with less. And I'm doing like Google Forms, the templates for my PMs, you know, and copying the results and pasting those in my work orders and stuff. So they just they would rather fill out a paper checklist and like take a photo of it and attach that to the work order. Some old school mentality. Very difficult to get a job without experience. You know something? That is very true. Because if you work at one facility for a long period of time, your experience is going to be very, very selective. A lot of people that stay in one spot for a long time, they work themselves into a comfortable position, which means they cherry pick the equipment that they work on, and they are good at their thing. And I believe that Biomed should be good at as much as possible. As much as possible. Let's see. Gia Steve says it would be really cool and would interest me if you could somehow do a video on cryostats. Oh my gosh, I had a cryostat. Not dang, you just reminded me. I had a cryostat work order that came in today, and that bad boy they say is not working right. Cryostats are very cool devices. They're make sure you wear gloves, man. That is some nasty stuff. But a cryostat is a device that freezes a material, or it takes a material that's already frozen, and it has a microtome, which is basically a very precise razor blade. And you have a micrometer that you select your depth of cut, and you shave off slices, cross sections of a usually a tissue, human tissue. So if you're looking at like a cancer cell or something, you're going to shave off, you know, layers of that cancer cell till you get a really good cross section, so that they can look under a microscope with different stains, and that way there they can figure out what percentage of the tissue mass is this type of material or that material or whatever. But so a cryostat, it's a very precise cold knife. Or optical stuff like microscopes and slit lamps. Man, I am so working on that. I have a microscope that I am currently working on at work, and it is an Olympus. And I if you guys didn't know, I kind of specialize in surgical microscopes, the big bastards that are the size of a Volkswagen that cost like $250,000. So I'm really good at those ones. These little ones are definitely a lot simpler, but I had one today that was popping fuses, and good thing Olympus still sells parts for this, because this is it's like a 15-year-old microscope or older, and they're still selling a power supply, the entire power supply on the back of this thing, and it costs $169. That's it, $169. As soon as I heard that, I almost jumped out of my chair. I could not believe that they're A, still selling the part on this old ass microscope, and B, it was only $169. It was the entire rear assembly. So it had your AC input, it had your power supply, and it had the whole back plate. It was all pre-mounted. And anyway, that part should be here tomorrow or the next day. I would love to get that on video and show you guys what's going on. I could definitely do sterilizers. Gia Steve, hold that note. I would love to do a video on plasma sterilizers. So steam, chemical, yeah. You want to get to the cool ones. Plasma sterilizers, very cool. And I know just the guys that would love to show the device. It's Biomed, who is up in Dallas, Texas, and I'm going to be going up to Dallas April. I guess this is a good time to tell you guys. I am going to be in Dallas April 16th and 17th at the MD Expo. Come on up, guys. It's going to be free if you're working for a hospital. Just go ahead and register through their website, mdexpo.com, I believe. And come check it out, guys. I'm going to be hanging out at the MD booth, MD Publishing, and over at the Biomed booth. Very cool guys. And they are experts on plasma sterilizers. So if you guys are going to be in the area, please stop by, man. I'd love to see you. Ames. Oh, my gosh. Oh, yes. It's been a while since I have seen Ames. Definitely. Around where I live, there's not many. Only other company I've interviewed with is Fresenius. Went through 2 interviews and they couldn't decide. Sent it to the boss to decide. Fresenius, in my opinion, is better. The reason it's better is they're a manufacturer, okay? And if you work with them, you're going to be going into all these different hospitals, and your experience is going to be way better than going with DaVita, because DaVita is a private firm that does dialysis, so they're dialysis clinics, and they have their own clinics. Fresenius is the manufacturer. A, you're going to get the best training on dialysis. And B, you're going to get a lot of experience because they're going to ship you all around to all these different hospitals. I would say that one is a win. Jag says, am I late? Which nurse call system is that? Jag, I tore apart a Hill-Rom power supply. It's a Hill-Rom power supply. And I went through the components inside it. It's not as complex as I thought it was going to be. There is no CPU controller in there. It is all analog. And I don't understand why we couldn't fix them. It's completely fixable. So carrying 20 or 30 of them like we currently are, I promise you that's not going to happen. When I go to work tomorrow, I'm gonna recommend to those guys that we get rid of most of those. There's no reason to carry 1 ton of these stupid power supplies. I'm not kidding you. I have shelves full of these power supplies. And it's like, why? Why do we have them? Because if it's broke, we can fix it. AIMS CMMS. You don't like it, Keith? I'll tell you what, I would take AIMS over Nivolo. Guys, I'm currently working with Crothel, and Crothel switched over to something called Teams Champs. All right, and so it's a version of Nivolo, and Team Champs is just like the Nivolo that I had before. And if anything, there's more clicks to close a work order than I had before, which was already, I think at the minimum, I had 38 clicks to close a work order before. So now I almost certainly have 40 to 45 at the minimum. That's not adding parts. That is not none of that extra request of PO or anything. Minimum, okay? He says it's good, but we use task checklists for procedures. Our old system fit everything on 1 page. AIMS puts it on 2 or 3. That's a good point. That's interesting. Okay. I used AIMS years ago. It's been a long time, so that's interesting. Which Hill-Rom system? We just opened a facility, and they went with Navicare. You know something? The new Hill-Rom systems operate completely differently than the old ones. So do not worry about some of the stuff that I currently worry about. Because the newer systems, you can remote in and you can manage it from your desktop. You know, you can manage your whole hospital from your desktop. You know, if there's a certain alarm that's going off, or if, you know, you have a room that's not communicating with the main board or something, you can diagnose it roughly from your desktop. Or from home, you can remote in if you have a VPN. So the new systems are very nice. And if you work for an old hospital, like I do, you deal with a lot of old stuff. It's just how it is, man. How do I feel about TriMedics? Woo, boy. You know, TriMedics is a conglomerate of several companies, and they're getting very big. And I have had people that work there that love it, you know, and I guess it's like anything. There's pluses and minuses to everything. And what could I say without getting in trouble? I mean, I've already been warned that companies they're watching some of these videos, and some people are getting pissed off and stuff. So I'll tell you one thing that's almost guaranteed with TriMedics. They're going to train you. Almost guaranteed, because they want you to be the most rounded technician possible. So if you go into a company like TriMedics, they are going to train you. So if you are currently working in a hospital and you feel like, oh, these guys never want to send me to training, you join TriMedics, and they're probably going to send you off to training. Guaranteed. They want you to be as learned as possible so that they can make as much money off you as possible. It is a for-profit organization. So They do what they do. Your company is working on your own CMMS system. I have had positive experiences with my own CMMS. Currently, I think the only reason that we went with Navolo is because somebody sold them some unicorns and rainbows about how Navolo will automatically interface with the test equipment. Oh my gosh. So I'm using Pronk test equipment, and I am using a whole bunch. I can't just say Pronk. I don't use Pronk. I am an old school Biomed. I still use like Impulse 4000, the Impulse 4000 and the MediTester 5000, stuff like that. I use the older stuff because, well, for profit, you know, I work for a non-for-profit hospital and my management is for profit. So, you know, we don't always get the newest and shiniest stuff, man. There was a bunch of techs got a lot of new test equipment, but I'm not shaking the boat. I'll just continue using the old stuff because it still works. It still works, man. Keith says, any recent experience with patient being injured or dying from microelectric shock? Are 100% electrical safety tests a waste of time, especially with so many detachable power cords? I have a lion heart, chicken heart. It's been in the field as long as I have. You are guaranteed. I just talked about the lion heart, chicken heart just a couple days ago with somebody. We had a good laugh about it. Still a reliable piece of equipment, man. Do you want the honest truth about that? There's going to be so many biomeds out there that are just going to get pissed off at this, what I'm going to say next. A vast majority of electrical safeties are an absolute joke. And it's not a joke. I shouldn't use that word. It's not necessary. It's not necessary because electronics today are completely different than what they were years ago. They're built differently. This is built completely differently than back when a lot of the people that are still maintaining those codes, like the NFPA 99, a bunch of baby boomers are still maintaining that code set. And a lot of the stuff that they're talking about, a lot of the components of electrical safety tests are from old school stuff, way back in the day when a lot of stuff was run off AC. Almost everything nowadays immediately gets converted to DC. Either they use an external DC adapter, or a lot of these devices immediately convert over to DC as soon as the power comes in, which, if you guys are older biomeds, you know that is not the way that it used to be. A lot of devices used to run motors off AC power. Well, let me tell you something. Devices are converting over to DC because DC is more regulated. There's less interference that the device creates. You can control speed better. I mean, it's honestly, the benefits of using DC power are so huge. And DC doesn't produce nearly the type of leakage or the quantity of leakage is using components with AC. All right. So even when you're using power supplies, which I probably have a couple of them floating around because it's me. Even when you are using power supplies, like any of these bastards right here, power supplies are not built the way that they used to be, okay? Even these power supplies right here, I've got dual fuses on both the line and the neutral. On medical grade power supplies, now I have filtering on line and neutral. I mean, mains is completely separated from your output, okay? So devices are not like they used to be, all right? So I'm telling you right now that leakage checks, I mean, if you were to go up to the average biomed, and I'm saying this, and this is gospel right here. I'm telling you the truth. If you go up to the average biomed and you ask them step by step to do an NFPA 99 electrical safety test, I would bet my whole paycheck today that 9 out of 10 people would not do that electrical safety check correctly. I will bet my whole paycheck that they will not do it correctly. It is the way it is. So if you're not doing the test correctly, a test that you do throughout your day, every single day for years of your career, if you can't even do that one check safely, then how necessary is that check? Just saying. Biomed should be able to tell you off the top of the head what version of NFPA they're using and what the results are, what milliamps, what milliohms, what microamps that you should be seeing. And like I said, 9 out of 10 biomeds could probably not tell you the correct figures. So it's just saying, it's one of those things. It's a dogma of our career field. Electrical safety checks. Now, some of them are necessary. Some of them are necessary. You know, I myself have spotted, and I got rid of a Jackson surgical table because I had 1 amp of leakage when I ran up one of the motors at one end of the surgical table. I had 1 amp. That is a lot of leakage. But guess what? Was anybody really going to get hurt by that? I highly doubt that. It would take a miracle for somebody to get affected by that, just because of the way operating rooms are designed, you know, the isolated power. I mean, there's so many reasons why that is not going to affect that patient. You're more likely to get hit by an ESU and hurt by an ESU than you would from any of this. I mean, think about it. You're injecting electricity into the body, and you are completely dependent on the medical staff on their REM pad placement, your return pad placement. Way more people get injured by ESUs than electrical shocks, okay? It's a joke. All right. Well, I shouldn't say it's a joke, but it's one of those tests that's completely not necessary anymore. And I'm sure a lot of biomeds are going to throw me under the bus for that. It is what it is, man. Let's see. Gia Steve says, at Keith, if top lead block breaks and lead connections become sloppy, I can send you a 3D printed replacement block of the file if you have access to a printer. Oh, that's so cool. That is very cool. Oh, you guys got me on a tangent here. I apologize for that. Electrical safeties are just one of those things. If people can't even do them correctly, of course I'm going to be upset about it. Because it's the one thing that you're supposed to be doing every day, right? Anyway, guys, wow, I have created one hell of a mess here. Guys, tomorrow is Thursday. It is going to be a very fun day. I am doing defibs this month, and I have so many defibs to do. It's so crazy, and I'm just overly stressed. So I am in here, and I'm just trying to relieve a little bit of tension. On that note, how about your comment on Megadyne pads? It's a very interesting question there, Dennis. Nobody ever tests the cord on those Megadyne pads, right? When you're dealing with consumables like the return patient pads, when you're dealing with the consumables, it's testing itself, right? Because it's testing itself for resistance when you plug it on the patient. The Megadyne pads operate on a different principle. And if I remember right, they operate on capacitive coupling. And I would love to do a video on what that pad does, because technically it's really amazing, because you can lay the whole pad under your entire patient and you can work on an extremity way down here, and you don't have to worry about surface burns because the surface of the patient has expanded. They are very interesting, and maybe I can get somebody from Megadyne to help out with the science behind those pads, because I have had a few of those pads go bad for sure, but they just keep on trucking. They're very durable. It's a well-made product. I'll give them that. But I would love to get somebody from Megadyne to answer me on that. Keith says, I get to go to the VA tomorrow for doctor's appointments and then off to a customer for PM. Gomco. What? Gomcos. Oh my gosh, I haven't seen a Gomco aspirator in a long time. A long time. It's good to hear that Gomcos are still out there. It's one of those pinnacle, one of those core pieces of medical equipment that I got started with back in the day. And it's good to see that they're still in service. Kind of like Bear Hugger 500 series, I think they are. I'm glad that I still see those every once in a while. Gia Steve says, just ran into a new one the other day. Vasometrics. What? Sensilaze Paddock unit. Apparently the company went out of business last year and no supported parts are available. Giant paperweight, embedded windows. No kidding. Very, very interesting. You're right, Keith. Back in the early 2000s, that's when I got involved with Gomcos. And I had the Gomcos that were the passive style, where it's a canister and all it is like a filament that heats up inside the canister. So it heats up and cools down. And I ended up taking one of those canisters out of that unit. And what the hell did I use that for? I think I used it for like a smoker or something. I can't even remember. It's so long ago. But I ended up using that Gomco canister for something else, and it worked perfectly. What Gomco that old? Man, Gomcos in general, they've been around for a while. And I don't know if Gomco as a company is still out there, but their equipment's still out there at least. Anyway, guys, I am going to cut this video off because I have got to go in and make sure that my kids are ready for bed. I appreciate you guys watching this. It was very interesting talking with you guys, getting to tear some really cool stuff apart. And tomorrow I've got some other stuff that I pulled out of the trash. I'm trying to figure out how to get it home. Maybe I'll go ahead and do the video on site. One of them being that microscope. It's such a cool problem with that microscope. I want to show it to you guys. So let's see if I can make that happen. All right. You all have a wonderful night. Okay. Thank you for watching.